In this lesson on Java algorithms, we will learn about search. So what is search? Search is about finding an element among a group of elements. So like finding a number in a telephone directory, finding the name in a school. So these are all elements of search. We are searching for a number in a telephone directory. We are searching for a name in a school. There are two ways of search that we will study: linear search and binary search. So what is linear search? In linear search, as the name suggests, we go through all the elements one by one till either we find the element that we were looking for or there is no element left in the group. Okay, so either the element is found or there is no element left in the group, and we go through all the elements one by one. So let's look at an example here. So here we have a group of numbers and we're looking for a number 20. So how do? We will start looking at the elements of the group one by one. So we will start with the left. We start with 10. No, it's not equal to 20. 8, not equal to 20. 25, no. 7, no. 9, no. 18, no. 6, no. 20, yes. So now we have found the number we were looking for, 20. So typically we would have run a for loop if this was an array of numbers. And now once we found the number, what would we do? We would break out of the for loop. And how do we then find out whether we found the number or not? So suppose we had a boolean found is equal to false, which we created at the start, and we created a variable index is equal to -1. And now once we found it, we will make found is equal to true before breaking, and we would put index equal to the index of the array where we found it. So now once we come out of the for loop, we know that we have found the value and we know its index. Suppose we were looking for a value like, say, let's say the value we were looking for was 12. So now 10, no. 8, no. We can keep on looking till the end. 11, no. So this value is not there. So in this case, the loop would have ended, and what would we have gotten? The found would have remained false. So the value of found would not have changed, and the index would have remained -1. So we know now that we have not found the element. So this is an example of linear search where we go through all the elements one by one. Okay. Let's look at a problem that we want to solve. Suppose we are looking for a page number in a book. Let's assume the book has 450 pages and the page number we are looking for is 180. So how do we find it? So suppose the rule we use is that we will always open the book in the middle. So now start page is say 1, end page we know is 450. So when we open in the middle, what will be the middle? Middle will be 1 plus 450 divided by 2. So it is 225. So we are opening it in the middle. So 225. Now once we open it in 225, we know that 180 is less than 225. So notice there is a pattern in a book. What is the pattern in a book? The pattern in a book is that all the page numbers are ordered. So page number 20 will always come before page number 30. Page number 100 is after page number 80. So now we know, because the mid is 225 where we open the book, the book will be the page that we're looking for. So suppose initially we look at 1,450 is where we're looking at. Now where will the page be? It will be to the left. So it will be between 1 and 224. Why 224? Because 225 we opened and that was not our page. So now what will we look at? So mid will now be equal to the middle of these two, which is say 112. Now 112 is less than 180. So now what should we start looking for? We will start looking from 113 to 224. This is what we will do. So we will look for a page between 113 to 224. Why 113? Why did we change this? Because 180 is more than 112, the value we got. So now what is the value we will look at? So mid will be equal to the half of this, so which is equal to say 168. Now because it's 168 and the page number is 180, so 168 is lower, So now we will start looking between 169 and 224. And now once we calculate the mid, what will it be? It will be mid will be equal to say 196 once we calculate it. Now what is 196? 196 is more than 180. So what do we change? So now we are looking for a page number between 169 and 195. So why 195? Because we checked till 196. So that's not the page. So we will be looking for one below it because 180 was lower than 196. Now when we look at the mid between these two, what will be mid be if we open it in the middle? So mid would be 182. So now what is 182? 182 is more than 180. So now what are we looking for? We will look for between 169 and 1 less than 182, which is 181. Now when we open it in the middle, what will it give us? It will give us mid will be 175. Now what is 175? 175 is less than 180. So we will start looking from more than 175, which is 176 to 181. Now what will be the mid of this? So the mid will be 178. So now once we look at 178, is 178 greater than 180? No, it is less than. So now we'll start looking from 179 to 181, and what will be mid be? Mid will be 180, and we have found the page. So notice in this case we were able to find the page by opening the book always in the middle. So always in the middle of what? Of the remaining pages where we had to look for the page that number that we were looking for. So how many steps would we take? 1, 2, 3, 4, 5, 6, 7, 8. In 8 steps we found our page number. If we were looking it like in a linear search, we would keep on flipping the pages one by one. So we would have looked through 180 page numbers to find the book page. And we would have not used this property that the page numbers in a book were sorted. So this approach that we have used is known as binary search. So let's look at one more example to understand binary search better. So suppose we're looking at the same group of numbers that we looked for earlier, and we are looking for the same number that we found earlier. So 20. So remember, this is what we did. We have the same group of numbers, and the number we were looking for initially was 20 when we found it. But there is one difference. The group of numbers are sorted, and they are sorted in ascending order. So we can notice that these numbers are sorted in ascending order, and we know that it is sorted in ascending order. So now we are looking for this page, this number between index 0 and index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So index 0 and 9. So our let's call start is 0 where we're looking at it. End is 9, which is the last index. So let's calculate mid. So mid is in between, which is 0 plus 9 by 2, which is 4. Now what is the value at mid? Value at mid is equal to, so value at 4, index 4 is 0, 1, 2, 3, 4 is 9. Now is 9 more than 20 or less than 20? It is less than 20. So now where should we be looking for the value? We will obviously look it between these values. So now what does start become? Start becomes mid plus 1, because we'll start looking to the right of mid. So it will become mid plus 1, which is 5. End remains the same. So end remains 9. And now what will mid be? Mid will be 5 plus 9, which is 14 by 2, which is 7. Now let's look at what is value at mid. Value of mid will be 0, 1, 2, 3, 4, 5, 6, 7. It is 18. Now what is 18? Is 18 more than 20 or less than 20? It is less than 20. So now our start will become equal to 8 mid plus 1. End will be equal to 9, and mid will be 8 plus 9, which is 17 by 2, which is 8. Now what is value at mid? Value at mid will be 0, 1, 2, 3, 4, 5, 6, 7, 8. It is 20. And is it the value we're looking at? So value found. So notice in this case we used binary search. Why do we call it binary? Because we are continuously making our consideration set half. So every time when we check for the mid, then we look either at the left or the right. So the set we are finding the value in goes down by half every time, and we found the value. Let's look at one more example. Suppose we are looking for the value 5 in the set. Again, like we did in the last example, we will start from 0. Our end will be 9, which is the index, and mid will be equal to 0 plus 9 by 2, which is 4. Now what is value at mid? Value at mid is 0, 1, 2, 3, 4, which is 9. Now 9 is more than 5, so the values will be to the left of it. It will be here. So now if it will be to the left of it, our start remains the same because it's to the left. And our end will become mid minus 1. Why minus 1? Because it's to the left. So this is where we will find the value. So now end will become 3. And where will we look for the value? We will look at the value at mid. Mid will be 0 plus 3 by 2, which is 1. Mid is equal to 1, and value at mid is 6. So the value we will find at mid is 6. Now what are we looking at is 5. So now is 6 more than 5? Yes, 6 is more than 5. So we will again look to the left. So when we are looking to the left, what will happen? Start will be 0. End will again be 0. And now mid, why will end be 0? Because it will be mid minus 1. And what will mid be? It will be 0. And now what is the value at 0? Value at mid is 4. Now if value at mid is 4, what is 5? 5 is greater than what we are looking at. So we will now start looking at the right. So now when we start looking at the right, start will be 1. Because it will be mid plus 1, and end will be 0. But we will have a condition that end should always be greater than equal to start. That is what we need, because we are looking for a range. So if this range is violated, means that there is no range we are looking at. So start being 1 and end being 0 doesn't make sense. So which means if this condition is violated, then we can safely say value is not found. So we will always check for this condition that end should be greater than equal to start, which means we have a range. If end is less than start, means there is no range. So in this case, we can safely say that value is not found. So this is how we use binary search to search for a value. So let's understand a couple of more examples, a couple of more features of binary search. So binary search is used when the group of elements is sorted. They could be sorted in ascending order, they could be sorted in descending order. So the examples we saw were when they were sorted in ascending order. We could similarly use binary search when they are sorted in descending order. Let's assume that the maximum numbers in a group were n. So in binary search, because it's becoming half every time, so the maximum number of searches we do is log of n to the base 2. So that is the maximum number of searches we do. In linear search, because we're looking at each element, the maximum number of searches we do is n. So this is why binary search is much more efficient. But remember, binary search can only be applied when the group of elements is sorted. So remember, whenever the group of elements is sorted, we will use binary search. Whenever the group of elements is not sorted, we will use linear search. Okay.